Okay, so we have the same learning goal. I can determine the effect of applying scale factor when we apply scale factor to the dimensions. What does that do to the perimeter, and what does that do to the area? That's what we're going to work with today. So when we are changing dimensions, I'm at the first arrow right here. When changing dimensions, it can be referred to as a scale factor. Now the book does not typically like to use the word scale factor, but it makes more sense. Here's the words they like to use: as a ratio of corresponding sides. So fill that in. When changing dimensions, we can refer to where?
No, between R and S.
It's an E right here.
Okay.
That's an E. Corresponding. Okay. So when we change dimensions, we can say that whatever that multiplier is, we can call it a scale factor. But here's what the book likes to call it, and you need to know that this means the same thing. The book will ask it as, what is the ratio of corresponding sides? Just like you did yesterday when you were doing that scale factor worksheet, that's why I had you do it. You were setting up a ratio of corresponding sides to find the scale factor. So you would take a side from the original figure, you would set up a ratio over the corresponding side of the new figure. Are you with me? You would take a side from the original figure, you would set up a ratio with the corresponding side from the new figure, and then you would simplify it if you could, and you would say that is the scale factor. So you actually were setting up a ratio of corresponding sides, simplifying it, and saying that was your scale factor. So your brain needs to right now make this connection. When they're talking about ratio of corresponding sides, they're talking about scale factor. They're the same thing, okay? So make that connection, right? Maybe you should underline this. They mean the same thing. So when the book asks you, what is the ratio of corresponding sides, you just replace it with these words if this makes more sense to you. What is the scale factor? Okay? So if the figure gets larger, we've been talking about this a lot, if the figure gets larger, the scale factor, or what I just said, we could also call that the ratio of corresponding sides, must be, how is it related to 1? Is it less than 1 or greater than 1? If the figure gets larger, is our scale factor greater than 1? Yep, it's greater than 1. If our multiplier, our scale factor, our ratio of corresponding sides is greater than 1, the new figure is going to be larger. Well, if the figure gets smaller, then what's the scale factor also known as the ratio of corresponding sides? Less than 1. And those are the connections you need to be making every time you're working in these problems. You need to say to yourself, did the new figure get larger or did it get smaller? Because that's going to help me make sense if I have a good answer or not. Okay? So when asked, this is a really important arrow right here. When asked for the ratio of perimeters, this is what they're going to do. So would you underline that? Ratio of perimeters or ratio of the areas. They're going to ask you, how does the ratio of areas change, or what is the ratio of areas? What is the ratio of perimeters? Here's what they're really asking you for, people. They're asking you for how, let's circle that part, how many times longer, that's perimeter, or bigger, that's area, the figure gets. So they say to you, what's the ratio of perimeters? You just need to basically think to yourself, how many times bigger or longer, or in perimeter is longer, how many times longer would the perimeter be? It might be shorter also, okay? Might end up shorter also. And bigger, it might also end up smaller. So they're really just asking you, how did it change? Did it get shorter or longer? Did it get smaller or bigger? Okay, let's do some practice here together, the kind of things you would be doing in your homework. We have a 4 by 5 inch photo that's going to be enlarged by multiplying each dimension by 2 to form a similar photo. What is the ratio of corresponding sides? You know what? I want us to write something down. I want us to underline this, multiplying each dimension by 2. What did they just give us right there? What did they just tell us? Anybody know what they just gave us right there? What important? Multiply the dimensions by 2, which is called the what? It could be called the ratio of corresponding sides. And what's another thing for ratio of corresponding sides?
Scale factor.
Scale factor. You know what? Let's just write that down. They just told us that the scale factor is 2. That's what they just told us. When they said that they're going to multiply each dimension by 2, they just gave us the scale factor. Okay, now one of the things we could do is, so it doesn't have to be so abstract, is we could make ourselves a 4 by 5 photo. And then we could enlarge that photo so that it is now an 8 by 10 photo instead, because we were supposed to double the dimensions, multiply the dimensions by 2, so wouldn't it be an 8 by 10 now? Okay. So now we're going to answer all these questions over there. What is the ratio of corresponding sides? So remember, the scale factor is also the ratio of corresponding sides, or this could be just like yesterday's homework. Take the new figure and put it over the old figure's corresponding side. So we could put 8 over 4, or we could put 10 over 5, couldn't we? And what do both of those simplify to? What's 8 over 4 the same as? 8 over 4? 2 over 1, also known as 2, right? How about 10 over 5? 2, okay. So it does sound like the ratio of corresponding sides is that scale factor of 2, isn't it? Okay, what's the ratio of the perimeters? Remember, what are they asking when they say the ratio of perimeters? What are they really asking you? What, Andrew? How many times longer it is? How many times longer is the new one going to be?
2 times.
2 times. Remember, whatever the scale factor is, that's what's going to happen to the perimeter also. Same thing is going to happen to the perimeter. What's the ratio of the areas? Remember, what does that mean? They're really asking you what? They're really asking you ratio of areas. What are they really asking you? How many times bigger did it get? Bigger or smaller? In this case, it's going to get got bigger, didn't it? Okay, so how many times bigger did it get? 2 times bigger? 4 times bigger. Where do we get that from?
By multiplying
The 2 times itself. Yeah, so 2 times 2, and our answer for that one is it gets 4 times bigger. So 4 of that photo should fit on top of the new one, the enlarged one. 4 of them should fit on top. Okay, questions on number 1 at all? Any part of that? Okay, let's go on to number 2 then, where we have a rectangle that has a width of 3 inches and a length of 12 inches. Each dimension of the rectangle is multiplied by 1/3 to form a new rectangle. I'm thinking that it might be kind of nice to have some rectangles here. We got a 3 by 12. Each dimension of the rectangle is multiplied by 1/3. Oh, is that important information? Right there? Yeah, multiplied by 1/3. What did they just give us? They just gave us the scale factor, didn't they? Okay, that's our scale factor. So if our scale factor is 1/3, would our new rectangle be larger than this one or smaller?
Smaller.
Better be smaller, huh? Okay, so we need a smaller rectangle that's now going to have what kind of Remember, multiplying by 1/3 is really the same as dividing by 3. What's 3 divided by 3? 1. Okay, so now the new rectangle has a dimension of 1. What's 12 divided by 3? 4. And the other side is a length of 4. So there's our new rectangle. So that kind of just gives us a picture so that when we're answering these things, hopefully we'll have, a better idea of what we're looking for. So how would the ratio of perimeters compare to the ratio of corresponding sides? There's all that language. Does that make sense to you right now? How do the ratio of perimeters compare to the ratio of corresponding sides? Okay, let's just take it apart here. The ratio of corresponding sides is what?
1/3.
1/3, because remember that's the same as the, what is this the same as?
Ratio.
Scale factor. Scale factor. It's the same thing there. Whenever they use the word ratio of corresponding sides, we're going to think scale factor. Okay? What's the ratio of the perimeters? 1/3 also, isn't it? Remember the perimeters, whatever the scale factor is, that's what the perimeter is going to change by also. So the perimeter is only going to be 1/3 as long now, isn't it? So therefore, we can answer their question, how would they compare? What would we say? They are both 1/3. Yeah. How do they compare? They are both 1/3. So the same. So whatever the scale factor was, that's how it affects the perimeter also. We would expect the perimeter of our new one to be 1/3 the perimeter of the old one, the original one. Let's see if we can quickly find the perimeter just in our head. What's the perimeter of the original one? 12 plus 12 is? 24. 3 plus 3 is? 6 plus 24 is? 30. This one has a perimeter of 30. Okay? How about this one? 4 plus 4 is? 8. 1 plus 1 is? 2. 8 plus 2 is? 10. This one has a perimeter of 10. Is this one, is 10 1/3 of 30? It sure is, isn't it? Okay. Okay, now we're going on to area. Now they're going to ask us how the ratio of area compares to the ratio of the corresponding sides. What is the ratio of the areas? Remember that means what? It gets how many times bigger or smaller? Well, it got smaller, didn't it? So our question is, how many times smaller did it get? Is it the same as the scale factor? Is it changed by the same amount as the scale factor? What does it change by? Look in yesterday's exploration, our conclusion at the bottom. The what?
Times itself.
Okay, what times itself?
Scale factor.
The scale factor times itself. So don't we have to take 1/3 times 1/3, which is, we're multiplying, not adding. 1 times 1 is 1. 3 times 3 is 9. It got a lot smaller, didn't it? So we would say, they wanted us, they said, how would, we got to compare. We're going to say the new rectangle is 1/9 the size of the original rectangle. Okay, I have a question for you. I'm not really sure of the diameter of the pizzas at Pizza Corner, but let's say, I love their taco pizza.
My dad works there.
Does he?
Yeah, he works 2 jobs now.
Awesome. So
So bring some like a orange pizza like every day.
We want to move it into your house. Okay. Is it taco ever?
Sometimes
It's my favorite.
less
So,
favorite ones.
let's say that I've ordered a 16-inch taco pizza. It's 16 inches across, the diameter is 16 inches. Okay, that's a dimension of the pizza. Okay, but you're like, you are really a big eater, Mrs. LeGrand. I can only eat half as much as you can. So what size pizza are you going to order if you can only eat half as much as me? An 8-inch? So you're going to have a pizza that's 8 inches across instead of 16? Because you can only eat half as much as me, remember?
No, I can actually eat more than you.
Oh, I'm sure that you think you can, but you probably can't when it comes to taco pizza. Okay, so just give me lots of sauce and I can eat a lot of taco pizza. So it's going to be it's going to be an 8-inch then? Okay, here's my taco pizza. Okay. Without the toppings or anything. Okay, here's my pizza. Okay, here's your pizza, the one that you said is the 8-inch. You can only eat half as much. That one. Are you going to get half as much pizza as me?
Oh.
Are you really going to get half as much pizza as me? How much are you going to get? Well, it's not going to fit on there, but what do you think? 1/4. 1/4. Because 16 divided by 8, what's the scale factor here? 2 or 1/2, right? You got 1/2. You took 16 and divided it in half. And you said, an 8-inch. But yet, remember what happens to the area? It doesn't get half as big. It gets a half times a half, which is 1/4. 4 of these would actually fit on here if we could cut it apart and cut, these pieces on and everything. You would only be eating a fourth as much as I am actually. So we gotta kind of try and wrap our head around how much does it really change by? We want to be tempted to think that if it's going to get half, the dimensions are going to be half as big. That means we're going to have half as much. No, we're only going to have a fourth as much. Because a half times a half is a fourth. Okay, let's go to the back side. Now let's see what we have to do back there. Okay. Oh, now this is very abstract. We have a square that has a perimeter of 48 centimeters. Each dimension of the square is multiplied by a scale factor, and the new square has a perimeter of 16 centimeters. What was the scale factor used? Well, there could be a variety of ways to go about this. Anybody think they have an idea what we could do? I'm trying to figure out what scale factor was used in this situation. What do you think, Adam? Thought you had a hand up.
I didn't think of them.
Oh, okay. Think it through. What do you think we could do in this? We got this square. It has a perimeter of 48 centimeters, so all the way around it, all together, is 48 centimeters. Then each dimension of the square is multiplied by a scale factor. They didn't tell us what it was, though. And the new square has a perimeter of 16 centimeters. Okay, so first of all, is the new square smaller or bigger? Smaller, right? So we have this square,
3 times.
and it got smaller. Okay? Right? Okay, go ahead.
Right, 48 divided by 4.
You could do 48 divided by 4. Okay, and what would that get us? If we took 48 and divided by 4, what would that get us? What's it going to provide for us? I don't even care what the number is. What's that? Why are you dividing 48 by 4?
Because that would give the measurement of each side.
Oh, that would. Yeah, because all the sides of the square are equal. So if we took 48 and divided by 4, we would now know how long each side is. Maybe that's helpful. So anybody know what 48 divided by 4 is? Adam? Okay, so that means every side of this square, the original one, has the side length of 12. Okay, maybe that's useful information. What else do we need to do now? Go ahead, Adam.
Well, if you just have 48 by 16, it's 20. So I'm guessing
If you divide 48 by what?
16,
16, it's what?
it's 3.
It's 3. Okay.
And I'm guessing that would be like the 16, like this 16 perimeter would be able to fit into the 48 perimeter by 3 times.
Oh, so you're thinking the perimeter of the new one is 3 times as long as the perimeter of the original one is 3 times as long as the perimeter of the new one? So it got 3 times longer? Okay. What do you think? So, remember, it says that the new one has a perimeter 3 times longer now. Do you agree with that?
I'm saying that it's shorter.
Okay, I think I know what you're trying to say, and I think also we'd have to do is flip our ratio. Remember, we always want to compare what? New to old. So could we flip this around, Adam, and do the new perimeter over the old perimeter? And of course, your calculator is going to give you this crazy thing called a 0.3 repeating, right? What is 0.3 repeating? 1/3.
That's kind of what I was doing with the other one, like I was gonna say 16 divided by 4 would be 3, or 16 divided by 4 would be 4, and then 4 over 12 would be 1/3, so that's kind of how I was going.
Oh, so then you said a ratio of corresponding sides. So you said 4 over 12, and that also equals 1/3. Okay. So here, this is what we call a ratio. Would you, if you're writing this down, I want you to label what we have here. We have a ratio of corresponding sides there. And remember, ratio of corresponding sides means the same thing as scale factor. Over here, Adam was setting up a ratio of perimeters. And what did we learn about the ratio of perimeters? It is the same as the scale factor. We got 1/3 there too, didn't we? So do you think we found the scale factor? Do you think we have found what they wanted? They wanted us to find the scale factor. What is it? It's 1/3. It's 1/3. So somewhere we have to write that the scale factor is 1/3. The scale factor is 1/3. Okay. Everybody convinced? Okay. By the way, even though, when we draw these, we just kind of sketch and we don't really worry about size, scale too much. We just get larger, smaller. How many of these then, if the scale factor is 1/3, this isn't part of the question, but I want you to think it right now for me. If the scale factor is 1/3, how many of these right here do you think are going to fit on top of that bigger one, the original one? 4?
No, 3.
3? 9. 9 of them. Because what's 1/3 times 1/3? 1/9. The area got 1/9 the size. 9 of those would fit on top of the original square. They weren't asking that though, I was just challenging you to it. Okay, let's try this one. A triangle has an area of 20 inches squared. Okay, so let's just draw one. Okay, 20 inches squared. And its area equals 20 inches squared. Okay? By the way, we can figure out how to find the area of this triangle, which would then help us maybe find the dimensions or come up with some dimensions that could work. But you know what? I don't want to work that hard, so please don't make me, okay? Each dimension of the triangle is multiplied by a scale factor. Oh, but they don't tell us what it is. And a new triangle is formed that has an area of 180 inches squared. Is the new triangle bigger or smaller?
Bigger.
Bigger. Well, it seems a whole lot bigger, right? So the area of this guy, the new one, is 180 inches squared. So when we're done, we better expect our scale factor to be what? Less than 1 or greater than 1?
Greater.
Better be greater than 1, right? Okay, Ratio of areas means how many times bigger did it get? How do you think we could find the ratio of the areas? I think that's what we should look for. Would you write that down? We're gonna set up the ratio of areas. New over original, so what's gonna go upstairs? What's going upstairs? 180. The new over the old. 180 over 20. How many 20s are there in 180?
9.
9. So the ratio of the areas is 9. Is that what they asked us for, the ratio of areas? No, they
No,
asked us
scale
for the
factor.
scale factor. Huh, is the scale factor 9 then? Well, then what is it?
1.
So if the ratio of the areas is 9, don't we need the scale factor times itself should equal that 9? Remember something, the scale factor multiplied by itself tells you how many times bigger it will get. So is 3 times 3 9? Yeah. So 3, the scale factor is 3. So it got 9 times bigger. The area got 9 times bigger. 9 of those original triangles would fit on top of the new one. But that does not mean the scale factor was 9. The scale factor is what got multiplied by itself to get 9. Well, that is 3. Okay? So this is the kind of stuff you're going to be tackling in your 5 problems of homework. Okay? Anybody have any questions that need to be answered at the moment?